Hello, this is my presentation for soil science by me, Robyn Tom. The site is in a backyard residence in Alhambra, and the area is adjacent to an alley right back here, and then an alley and a busy restaurant down here. The entire backyard has been converted into a dog play area, separating the edible garden with a fence between both of the areas. So the edible garden dimensions are 82 by 14 with a total area of 1,148 square feet. The site has been divided from the front over here, the west in the middle, and the right is the east side of the garden, with concrete paths splitting the east and the west side. This is the west side of the garden, and this is the east side of the garden. So the site was previously inhabited by tenants with unknown usage. The satellite image shows that cars were parked in the backyard along with other unknown storage. Earlier work in the garden provides evidence of plastic BBs scattered along with random plastic and metal debris. So possible oil or other contaminants may have been poured into various landscape areas. A current problem is an influx of oxalis, yellowwood sorrel, which grow prolifically by rhizomes and bulbs and can spread seeds up to 10 feet away when pulled out of the ground. So most of the areas were compacted over time, and there seems to be a slight drainage issue in several locations, making it evident by moss and mushrooms, but that could be overwatering. So the plant profile for this term project will focus on Murasaki purple peppers with the seeds coming from Baker Creek. These peppers are small, long, and not spicy. The peppers prefer full sun with 60 to 90 degree Fahrenheit temperatures. It also prefers sandy loam, fertile, well-draining soils at a pH from 6 to 6.8. The highest salinity tolerance of the crop is 1.5 decisiemens per meter for soil salinity and 1.0 decisiemens per meter for water salinity. When irrigating, peppers prefer drip irrigation at a rate of 1.5 inches per week, making sure that it is always below 30 centibars. So on a large farm scale, it prefers these nutrient requirements over here of nitrogen, phosphorus, and potassium. So for the at-home soil tests, I was unable to form a ribbon with this soil. It just fell off in chunks, but I was able to form a ball. It felt gritty, so I felt that this was a sandy loam type of soil. Doing the jar test and waiting for sediments to settle, I measured these increments over here and I converted them to percentages over here. And according to the soil triangle, I have sandy loam. For the compaction test, I found this 36-inch metal rod and hammered it into the ground as far as it can go. Here's the top, and there's the top there. So there was no compaction at this specific area, but I do know that from digging that there are definitely other areas that have compaction issues. Infiltration tests. I left this part of the can out of the ground and filled it with water 3 times. And these are my infiltration times, and it showed quick drainage. So after some calculation, I measured the infiltration rate at 90 inches per hour. For the percolation test, I put a bamboo stake into the ground to mark where the bottom was, which is the bottom of this orange tape, that's ground level. And I filled the hole with water and measured how far the water percolated down after an hour. So after 1 hour, the water drained 8.5 inches, making the percolation rate 8.5 inches per hour, which I now know is incorrect, but I'll explain that in the next few slides. The soil test results from Waypoint Analytical look like this. So considering the lack of care that went into this area before deciding it was going to be a garden space, I'm surprised that the soil test came back pretty okay. Everything seems to be at optimal levels except for the lack of nitrogen and the excess of phosphorus. The results for salinity, sodium absorption ratio, and sodium are negligible. So lucky for me, I don't have to worry about these. And my pH tested at 6.9, and for most ornamental or vegetable crops, a pH of 6.2 to 7.5 is ideal, so my soil does not need any remedies. This is a closer look at the macronutrients and some micronutrients, and the only thing that shows deficiency is the nitrogen, and it also shows a phosphorus toxicity, with everything else being optimal. So according to the test, I have a loam soil with this half-sat number. The Western Fertilizer Handbook estimates that I have an infiltration rate of 0.25 inches per hour in a loam soil. My texture and jar tests were similar to as I found it to be a sandy loam. But I believe these results are much more accurate as I performed the infiltration and percolation tests incorrectly, and I needed to wait longer to pour more water, especially for the percolation tests. So these are the nutrients that I need to fix, is the nitrogen and the phosphorus. And so based on the lab results, the deficiency and the deficiency in nitrogen and the toxicity of phosphorus, I can't do anything about the phosphorus level, and according to Bill Darlington, this will go away over time, but I can add fertilizer with high nitrogen levels to try and remedy my nitrogen deficiency. So I found feather meal with 1200. And this is a high nitrogen fertilizer that can be incorporated into the soil. So looking at the nitrate levels over here and the ammonium levels over here, I can calculate how much fertilizer I need for 1,000 square feet, which is 11 pounds. And since plants have already been planted and there's not enough time or energy to incorporate 11 pounds of the feather meal into 1,000 square feet, I plan on top dressing or applying a little bit of the feather meal on top and watering it in according to the directions on Down to Earth. For new transplants, add 1 to 2 tablespoons per hole, mix into soil and water well. To feed established plants, side dress 2 to 4 ounces depending on the plant size, desired growth rate for each month during the growth season. So my first application was on the 21st, and I will continue monthly and making sure that I water deeply afterwards. So the issues that I do have to resolve is compaction. There was compaction in other areas, and I plan on growing daikon in late fall as an edible plant that can break up the soil. Irrigation, I plan to install drip irrigation later, but watering it by hand is what I'm doing now, and hand watering also allows me to inspect the plants to identify for pests or diseases. And the nitrogen deficiencies, I am adding the feather meal, and I will be planting fava beans or other legumes as they put in more nitrogen into the soil. Other techniques to improve soil quality include heavy mulching and it'll retain the moisture in the soil as well. So back to the west side of the garden. This picture was taken on March 8th, 2021, and recent pictures, this picture is taken of the garden on May 26th, so 2.5 months later. So here's the east side of the garden, and another set picture of the east side of the garden. The tarp is so that my brassicas don't bolt. And so finally I did plant my seeds, and this is a baby Murasaki pepper plant. Thanks, bye!